voltage is greater than normal value. So the voltages which will be greater than the normal value, or we call it operating voltage. And voltages which are greater than the normal value, or also if there is a power system and there is an rating of an operating voltage, if that voltage is greater than that normal value, that means whatever is the operating voltage in that system, that voltage is said to be a over voltage. We call that as over voltage. Okay. So over voltage, what are the causes of over voltages? So over voltages, uh, first before the causes, how they occur. It's very important that how the over voltages occur. Over voltages occur both as a rise in voltages. They can occur as a rise in voltages, rise in voltages between phases. That means if there are three phases in the power system, so any phase between A phase, B phase, A and B phase, B and C phase, C and E phase, so it can occur between any phases, or it can also occur between a phase and a ground. That means a ground also between, and it can also occur between phase and ground. So what is an over voltage? Over voltage is a value of the voltage that is more than the normal value or an operating voltage of a system. And over voltage, when it occurs, how it occurs, it will occur between two phases of a power system, between phases of a transmission lines, or between phase and a ground. It can also occur. What are the causes of over voltages? Causes of over voltages are, there are reasons for over voltages. Over voltages are caused due to many reasons. There are lots of reasons, but main reason is, number one is lightning. We'll talk about this lightning in detail. Lightning phenomena is there, or it's about opening of a circuit breaker. So lightning, or it's the opening of a circuit breaker. It means whenever there is a fault will occur, so we need to open a circuit breaker in order to isolate that faulty part. So over voltage can occur there, but sometimes due to defunct operation also circuit breaker can occur, or sometimes there can be also over voltage may occur due to when there will be grounding to the conductor. There will be a conductor will be grounded. That means maybe one of the conductor, one of the line will fall on the ground, just like a LG fault, grounding to conductor, yeah, grounding of conductor. So lightning, opening of circuit breaker, grounding, these are the causes of the over voltages on the power system. So first definition is clear. So any voltage that is greater than the normal voltage value, or whatever has been set on the power system, what is the operating voltage of the power system on the distribution side or on the transmission side, whatever the voltage is there, if it is greater than that, that value will be set as an over voltage. And then second, it can occur between two phases of a transmission line or between a phase and a ground. Then causes are main. Lightning is the main cause. We'll discuss this lightning in detail. Opening of a circuit breaker, and then grounding of the conductor is another reason for this. Next is voltage surge. Voltage surge is another definition which we should know. A sudden rise voltage surge is what? Voltage surge means increase. We know that we have seen that surges. Surge mean increase. The voltage rise in a voltage for a very short duration, for a very short time, is called a voltage surge on a power system, or it's also called a transient, and the name is given to it as an transient surge. So it's a sudden, there is only difference is voltage surge is that it's a sudden rise in the voltage, but it's for only for a shorter time. Sudden rise in voltage for a short duration. Sudden rise in voltage for a short duration on a power system is known as, what is this? Voltage source. So it's also sometimes named as a transient surge. Transients, or whatever the surges we call them, they are the nature of these, all these voltage surges or transients. These nature of these is temporary. They are temporary in nature. They will exist for a very short duration. So nature is, it's a temporary nature. They're not permanent. Temporary, they are of temporary nature, and they will, already I have told you, they will exist for a very short period. Maybe the period, if we talk about, is few microseconds. Few microseconds. So very they are temporary in nature. They will not be permanent in nature. They will exist for a short duration, and that short duration is very very short. few hundred few hundred few hundred microseconds, but they will cause over voltages on the power system. Now, what will happen? Somebody will tell, sir, if these surges are there, then what's going to happen? When these surges will occur on the power system, they are dangerous to the electrical equipments, whatever the electrical equipments we have installed. So these surges are dangerous to electrical equipments. Whatever the equipments we are installed, they will be dangerous to those equipments. Now, they will originate, how they originate? They originate from switching and from other causes also. So, but most important is transient. Most important is transient, and when we talk about the transient, they are those which are caused by the lightning phenomena. That means when the lightning strikes the transmission line. So we can see they will originate from switching. What is switching? Basically, switching, when we talk about, that was the change in the network. Whenever there is a fault on the transmission line, so we need to isolate. Relay will give signal to what? To a circuit breaker, and circuit breaker in turn will isolate the faulty part from the healthy part. So then the nature or the shape of the network will change. That's also called as switching. So what will happen if fault will occur? The voltage surge can be there, and but the main most important transient, or the most important cause of this transient surge or the voltage surge, is the lightning striking the transmission line. So this is the most important. Lightning, as I've already talked, lightning striking the transmission line. That's the most important cause of this uh, voltage surge. So what will happen in this case? When the lightning strikes the sea, this is the way you have a transmission line. This, what nature has done good for us, the lightnings will always strike near to or adjacent to transmission line. It will not be on the top of the transmission line always. What nature has done very good for us is that lightning will strike adjacent to the transmission line or near the vicinity of the transmission line, but for the lesser percentage they will strike on the top of the transmission line. But in case this lightning will strike on the top of the transmission line, then what's going to happen? The voltage surge will be formed, because this will contain a discharge, this will contain a charge, and that charged lightning will strike on the transmission line. We will discuss this in detail in the coming, maybe in this lecture or in the coming lectures. So then what will happen? A surge will be developed that will start moving from one side of the transmission line. Surge will rush or it will develop, and that will move along the length of the transmission line in the most of the cases. Such when such surges when such surges will reach to the line insulators. So when the surge has been developed and that will start traveling along the length of the transmission line, and when such surge reach near to the line insulators, or maybe the lightning can strike near the light insulator, then the flashover will, at that point of time, what will happen? A flashover will take place. Once that flashover will be placed, that may damage, that flashover will take place, and that flashover will damage the nearby transformers, that is the equipments installed, transformers, or it can also damage generators or other equipments which will be connected to the which will be installed on the transmission line, if that is not suitably protected. It will only happen if there is not suitable protection. But if there is suitable protection, then this can be avoided. So uh, I'll explain this again. So what is happening? When the lightning will strike the transmission line, these surges will start moving fast along the length of the line, and in if maximum cases, such surges cause the such surges when they reach near the line insulators, and maybe near the point that is also the point where the lightning can strike, then a flashover will take place. What is going to happen? A flashover will take place. Flashover means sort of sparking will take place, which will contain some fire in it, and that flashover, as a result of that flashover, nearby equipments whichever are present in the transmission line, those equipments will get damaged if the line will not be adequately protected. That is very important for us. So next is protection, how we can make protection against over voltages. So next is how we can make this protection against the over voltages. Okay, over voltages, when they will occur in the power system, they are divided into the three categories. So over voltages are divided into the three categories. So number one is an external voltages. Second is direct lightning strokes. Third is direct lightning strokes. Then, sorry, this is not the cause. Category we are talking about. So external voltages. Second is internal high frequency voltages. Internal high frequency over voltages. Third is internal low frequency over voltages. Okay, so we're talking about the protection against overvoltages. First of, overvoltages are divided into three categories: external overvoltages, internal high frequency overvoltages, internal low frequency overvoltages. These are types. Now, number one, we'll be talking about external overvoltages. External overvoltages. Okay, these are now external overvoltage. When we talk about this, is external. That means external to the power system. So these are, what are the nature of these? These are atmospheric in nature or in origin. So origin of there is atmospheric. So whatever there will be from the atmospheric, the nature of them will come from the atmosphere itself. So they are of atmospheric nature, and they will, how they will form? They will take the form of unidirectional pulse. What is the meaning of unidirectional pulse? Impulse. So unidirectional means they will come from one direction only. That's from the atmosphere. That's from the outside the transmission line, outside the power system. Maybe due to the bad weather, due to lightning and other causes, they will come from there. So they will come from one direction, unidirectional pulse. That's why they will not come from any other direction. They will come from atmosphere only. So the maximum, whatever the amplitude of this voltage will have, that voltage will not be having any direct relationship with the operating voltage of the system. So maximum amplitude. So if whatever the maximum amplitude of this external voltage may be, maximum amplitude, whatever the amplitude of this voltage may be, that is not going to have any no direct relationship with the operating voltage. No direct. It's very important. No direct relationship with operating voltage. So it will not have any relationship with the operating because it's external from the system. It's not internal. So whatever the voltage will come, that will have a one directional pulse, impulse will have, whatever the impulse that is having, and whatever the amplitude of that may be having, that will not be having any direct relationship with the operating voltage of the power system. What are the main reasons for this? What are the reasons for this external over voltage? The main reason for this is the reason means what are the causes of this external voltage? Number one will be direct lightning stroke. Direct lightning stroke. So that will be number one cause. So whenever the direct lightning stroke will fall on the transmission line, there will be generation of voltage. As I have told, voltage surge will start traveling along the length of the line, and they will move from one side to another side, and that voltage may increase in its value if adequate protection will not be provided in the power system. So number two is there will be induced voltages that will be caused by lightning discharge that will take place to earth near the line. So second will be induced voltages caused by lightning discharge taking place to earth near the line. So whatever the voltage will be induced, maybe once the lightning discharge will fall on the transmission line, and that transmission line, that discharge will uh, take place on the transmission line, and that the discharge in connection with the earth, that can also result in the over voltages. So that means a lightning discharge will be there from the transmission line to earth, and that can make a line to ground type of fault, and that will increase the voltage. So that's also the cause of the direct. Next is the voltage is induced by the varying atmosphere conditions. Induced by varying atmospheric condition. So sometimes the atmospheric conditions may change. Sometimes it is hot, sometimes there is lightning, sometimes there is rain. So all those conditions, when these conditions will vary on the length of the transmission line, the voltages will be induced, and the atmospheric varying this condition, that means different types of atmospheric conditions can increase the voltage, and that will have no effect with the operating voltage of the system. So that will be external over voltages. Next is then there will be electrostatically induced over voltages caused by charge clouds. There is electrostatic induced voltages that is caused by charge cloud. So voltages, electrostatic, whatever the voltages will be there, induced voltages will be there. Electrostatic voltages, that means electrostatic. When we talk about electrostatic, what is the meaning of the electrostatic? Electrostatic charge will deal with what? Phenomenon and properties of stationary, or the charge which is very slow moving charge. That means it has no acceleration. That's the electrostatic. I'll again repeat it. It is the type of the phenomenon in which the charge will be stationary, it will not be moving, slow moving rather, we can say very low slow moving, acceleration will not be there. So when that electrostatic charge will be induced, that will also induce over voltages on the charge cloud. So we will talk about this charge cloud, how the cloud will be charged in the lightning phenomenon, and that charge cloud can also raise the voltage externally. That's an external over voltage. Next is electrostatic induced voltages caused by frictional effects of what? Small particles. So induced voltages caused by frictional effects of small particles in atmosphere. So again, electrostatically induced, that means which is a slow moving charge, which has not got much acceleration, which is a stationary charge, that can also induce voltages. So that will be caused by what? Atmosphere, there will be some, maybe there is a moisture, there is a rain and other effects in the atmosphere, that small particles will be present in the atmosphere. And because of the frictional effect, there will be one another, they will develop a friction. As a result of that friction, we can have an increase in the voltage, and that voltage will be externally increased. I hope Moomin it is clear.
Yes, sir. It's clear.
It's a simple it's a theory type of next is internal high frequency voltages. Second is so that internal high frequency voltages, they will be caused due to the transient phenomenon, which when they will be caused, what is the reason for this? They will be caused due to transient phenomenon. Internal is the name, so because of the network change, transient surge, so something fault will occur because of these reasons only. Internal is the reason. Now this is due to the power system itself. This is due to the power system itself phenomenon. So they will be caused due to transient phenomenon, which will arise, how it can be developed, how it can occur. when the state of network, when the network state will change. So this will arise due to network change. That will state of network will change. How? That will change by switching. Switching we have talked about, maybe the circuit breaker will be switched off, circuit breaker will be opened. So we will have three transmission lines where the voltages will be developed between phase and neutral. So when the normal phenomena will be there, all of a sudden we will open a circuit breaker, then some healthy part will be uh, allowed to flow the electrical energy. Just a second. Hello. Uh-huh. Aslında niye telsiz getting president function class Okay, so that will be due to network changes, and network changes will be as a result of switching operation or switching operation. I have told you, switching operation is whenever the fault or circuit breaker may open, that will change the network, or that can also result as a fault when there will be a fault condition in the network, fault condition in the power system. So internal high frequency voltages, whenever we talk about, they are due to what is the reason for what is the reason for developing these internal high frequency voltages. Reason are transient phenomena, and transient phenomena, that means all of a sudden there will be a surge in the voltage that can occur, that will arise when the state of network is changed. How the state of network can change? That can change by switching operation, or that can change by fault condition. Network, whenever we talk about the network change, there may be a normal switching operation. So that's what I was talking about. Whenever we talk about the network change, so it's a switching operation. What does this switching operation mean? Switching operations such as opening of a circuit breaker. I was just talking about the same opening of the circuit breaker. Okay, network change means switching operation, that means opening of the circuit breaker, or it may result due to fault conditions, such as there can be line to ground fault. If the line to ground fault occurs in the on the power system, line to ground fault occurs on the power system, it can also lead to increase in the voltage, but that voltage will be result as an internal increase, which may have high frequency. Now frequency of this, whatever the voltage has been increased, whatever the voltage has got increased in terms of amplitude, in terms of magnitude, whether sorry, whether that is due to switching, whether that is due to opening of circuit breaker, whether that is due to line to ground fault, transient will occur, certain surge in the voltage will be there. The frequency of that resulting voltage, whatever the voltage has increased, which will take the form of damped sinusoid. We have talked about this in the control system, will be damped sinusoid. So there will be a sinusoidal voltage, but that will be damping. Some amount of damping will be done on this. Okay, some amount of damping will be damped sinusoid. Maybe that's damped sinusoid, maybe in the range of 20 kilohertz. So very high frequency will be there. So I'm again emphasizing on this point. The point is that frequency of this resulting voltage, which is which will take place, which will take the shape of the damped sinusoid, and that frequency will be of the range of, or of the value of, nearly to 20 kilohertz. It is grounded, will be grounded by, there will be a capacitance and there will be inductance of the circuit. So capacitance and inductance of the circuit will be involved in the circuit. Okay, so that was internal sorry internal high frequency, yeah. So lost is internal low frequency. So these occur internal low frequency over voltages. How they occur? They occur at the power frequency. Power frequency means normal frequency. In India is 50 hertz. Other foreign countries will have 60 hertz. So they will occur at the power frequency. Why? They can occur due to loss of load. So they can occur. Why they can occur? How they can occur? They can occur due to loss of load, particularly that on the transmission line. So they can occur due to loss of load on the transmission line. This is the internal high frequency, low frequency voltages. So you can see here I have drawn one typical wave shape of a typical lightning surge. So you can see this is T1 time and T2 time. So this will reach to the peak. So this is wave tail, this is maximum, this is half of the maximum here. You can see half of the maximum is here. So we were talking about this is a damped sinusoid. Of course, this is a damped sinusoid. It will increase and then it will be, this will exponentially decay. So that we already called as this underdamped system we have. So it's a damped sinusoid. It's a sinusoidal wave, but it has been damped in this case. So this is a wave tail. This is a time versus the voltage. Time versus the voltage. This is the wave shape of the lightning surge can be of this shape. Okay, so this was something about uh, over voltages and causes of those over voltages. So next phenomena we have, next phenomena is the lightning phenomena. We can write it here. So next phenomena is the lightning phenomena. So next is height of what a consideration we have to consider in the lightning phenomena. Number one will be height of the cloud. So on the basis of this, we'll be explaining this. Height of cloud, that is around 500 to 30,000 feet. Charge centers responsible for lightning. Charge centers responsible for lightning, though that will be uh, how much above the earth, that will be 1,000 to 5,000 feet. There will be charge centers. Next is maximum charge on cloud. Maximum charge on a cloud will be 10 coulombs. So that will maximum charge on the cloud, which will be considering is 10 coulombs, and that will build exponentially. That will increase exponentially. That will increase. Okay. So next, what we are considering, maximum potential of cloud. Maximum potential of cloud. So how much that is to be? That is 10 megavolts to 100 megavolts we are considering. That's a maximum potential of the cloud. So next is energy of lightning stroke. So what is the energy of lightning stroke? Energy of lightning stroke will be around 250 kilowatt hour. Next, size of raindrops what will be the size of raindrops is 0.25 centimeter in dia. Okay, if velocity of air is more than velocity of air is more than 800 centimeters per second. So velocity of air should be more than that size will be 0.25 centimeters dia. Okay. Now let's explain the lightning discharge. First, you have to remember cloud and earth when there are what is the we have a cloud and we have here earth. This is one of the theories. The theories is not 100%. Still, we have research is going on this, but one of the theory is given by Simpson's theory. This is one of the theory. So that is most accepted theory in the literature. So cloud and earth, they form what basically how it is explained this theory. Cloud and earth forms two plates of a gigantic or a big capacitor. So they will form two plates of a very big, we call gigantic capacitor. So cloud and earth. And the air which is in between them is known as that's a dielectric. Air will be considered, whatever the air between them is air, that is considered as a dielectric. So in such manner, we can say that this is in the form of a capacitor. So since the lower part of the cloud will be is negatively charged, we will always see that lower part of cloud is that will be negatively charged, and the earth then earth will get positive charge by induction charge. So earth will get positive charge by induction phenomena. So we'll see that. So first what we have, what is in this theory, lightning phenomena, we have to consider all this. On the basis of this we are explaining it. Next is that one accepted theory in this case is that cloud and earth are forming the two plates of a big capacitor. We called it a gigantic capacitor, and air acts as an dielectric. So since the lower part of cloud is negatively charged, then the earth will get positive charge by induction. So how the lightning discharge will start? Let us see now. Now, lightning discharge will take place how? When a cloud is raised, when the cloud which is present in the atmosphere will be raised to such a high potential with respect to Earth. So, when a cloud will be raised to high potential. So, when the cloud will be raised to very high potential, but that is with respect to Earth. One thing. Second, or to the neighboring cloud, or it can be between two neighboring clouds. Neighboring, or it can be between neighboring clouds. So lightning discharge will take place when the lightning discharge can take place when we raise the potential of a cloud to a very high value with respect to Earth, or it can occur between two neighboring clouds. Now, what will happen when this discharge lightning discharge takes place, then what will happen? There will be an insulating property of the surrounding air because we have talked about that it's like a capacitor where we have one side cloud and another side earth, and in between them air will act as a dielectric medium. So what will happen when the discharge will take place? The insulating property of the air will get destroyed. That means the insulating property of this air will get destroyed. So this is the first thing. How it occurs? It will occur between a cloud, and when the cloud is raised to a very high potential value with respect to Earth, or between two neighboring clouds, it can occur. Lightning discharge can take place. Once this takes place, whatever the air is surrounding that, insulating properties of that air will be destroyed. And also it is thought that the raising of potential may be also due to frictional effects or by atmospheric disturbances. So this is also considered that the potential of the cloud may be raised due to frictional effects. Frictional effects also can be there that can raise the temperature. Also, it is thought that by atmospheric disturbances acting on the particles forming the clouds. So, whatever the particles which are forming the clouds, and then outside there can be atmospheric disturbances. If there are atmospheric disturbances outside the cloud, so that can also result in the lightning discharge. So I will again talk about this lightning discharge. Lightning discharge will take place when it can take place when a cloud is raised to a very high value with respect to Earth or to a neighboring cloud. Then what will happen? The insulating properties which are surrounding that air, so that will get destroyed completely, or the potential can also be increased due to the frictional effects, or that can also occur the particles which are forming the clouds. Maybe there is some atmospheric external disturbance that can also result in the high potential. Now first process, now this process of actual lightning discharge, what will happen? We have talked about this. So there will be raising of potential gradient. We call it potential gradient. So first, the starting part of the lightning phenomenon is, so potential gradient will be raised. Raising of potential gradient. And we have seen what are the reasons. These are the all reasons how the potential gradient gets raised. So in this process, the first thing is that potential gradient is raised, raising of the potential gradient in air. That will be in air that will be surrounding the cloud. So we will increase the potential gradient at that. Now, once the potential gradient will be increased, that will result into the breakdown. That will result in the breakdown, giving rise to corona discharge. So when this potential will be increased, when the potential will be increased in the air of the surrounding cloud, so whatever the cloud will be there, when we will increase the potential gradient at that, what will happen? A breakdown will occur. So after that, because there will be a threshold value, and at that threshold value, a breakdown will occur. That breakdown, once it will occur, it will give rise to corona. We have talked about this corona in the power system 1. That will give rise to corona discharge. So when that will give rise to the corona discharge, that we will call as, that will be called as pilot streamer. I'll show you. Or in other words, what we can also see, when the potential of that cloud will be raised to a value, to a very high value, due to above reasons which I have given, the breakdown of that will occur. When the breakdown of that occur, then corona discharge will take place, and that is called a pilot streamer. Or in other words, we can say also that local concentration, whatever the charge will be present locally, the local concentration of charge near the cloud, the potential gradient there will increase to an extent. How that will increase? The potential gradient will increase, or that will exceed the value more than the breakdown value, which is called a critical breakdown value. We have seen in corona, critical breakdown value, and that critical breakdown value is 30 kilovolts per centimeter. We have seen in this corona discharge. So whenever that breakdown will take place and the value of that potential gradient will be greater than the critical breakdown value, and that value is 30 kilovolts per centimeter. Okay, the air, what will happen? Now when that will happen, the air surrounding will get ionized. Then in that case, whatever the air will be there, that air will get ionized, and as such, what will happen? Once the air gets ionized, then the electrical streamer will start from a cloud. Will start from where? From cloud towards the earth. The streamer is known as the pilot streamer. So this is known as the pilot streamer we will talk about. So again explain it. So first point in this is to raise the potential of the cloud. Once the potential is raised of the surrounding cloud, then what will happen? It will raise to a threshold value where the breakdown will occur. Once the breakdown will occur, the corona discharge will take place. Once the corona discharge will take place, how it will take place? Because in this case, there will be a charge present locally. The concentration of that charge will be very high, and when that concentration of charge will increase the potential gradient more than the critical breakdown value, then what will happen? A streamer means a stream of charges will start from cloud towards the earth, and that streamer is known as pilot streamer, and it leads to lightning phenomena. That will lead to lightning phenomena. That's a pilot streamer, and that will lead to the lightning phenomena. You can see it from this diagram. See? So once earth, here it will be cloud, or bottom of the cloud will be negative charge. It is positive charge at the top. Earth will get induced charge by induction. It will get a positive charge. So what will happen when that concentration will go very high and the potential gradient will increase? When that will increase, now what will happen after that? A discharge will take place. Once the discharge will take place, the local concentration of charge will be having very high potential, and that value can go beyond the critical breakdown value, and a stream of charges, which is known as the pilot streamer, will start from the cloud and it will start moving towards earth. See, this is the main branch, is the main line. This I'll be talking about this. I'll be highlighting this. This main streamer start from the cloud and that will start towards the earth, will be called as the pilot streamer. Okay, this is up to here. Now after that, what will be happening? After that, depending how much the ionization has take place. See, there from here ionization will take place. Here ionization is going to take place. Depending whatever will be the magnitude or whatever will be the intensity of the state of the or intensity of the ionization, the air which is surrounding this streamer. So this streamer has air, this pilot streamer has air on the left and right hand side of it. It will be, then it will, what will happen? It will branch into several paths. So see, we have a branch number 1, we have a branch number 2, branch number 3, and so on, branch number 4, branch number 5. So it will be branched into several paths. So these are all branches we are talking about. This is all branches we are talking about. And it will be known as the step leader. So what are the branches will be after that pilot streamers? How much of the intensity it will have, how much of the ion concentration it will have, how much of the state of ion it will have, magnitude of the ion concentration it will have. It will have the step leaders, and those, it will have branches. Those, there will be several branches. Those branches will be called as side streamers. And now it is very important that the step leader, so this is a step leader and this is called a side streamer. Then what will happen? The step leader consists of series of steps, and these steps, this is step one from here, step 2 from there, after the branch, after next branch, next step. So we will have, here step. So there it will have number of steps. So it will have number of steps, and at each step there will be a side streamer on this. Those step leader will consist of a series of steps, and those steps will be these steps will be 50 meters in length. So those steps will be 50 meters will be length, and those steps will involve what? They will be having side streamers on the left and right of it. So it will be having side streamers on the left and right of it. Now after that, what will be happening? Depending upon the charge which will be brought from the cloud. So we have brought some charge from the cloud here. On the top here, from here, we are bringing some charge. So depending on what are the intensity of the charge we'll be forming, we'll be drawing from this cloud through already this path is ionized. See this up to here, we can see this path is ionized. This all path is ionized. Then what will happen? There will be pauses. See, there can be pauses, one pause, second pause, third pause, fourth pause, wherever the side streams are. There will be a number of pauses. The air surrounding these pauses then again will get ionized, and the leader in this manner will reach to ground. So I will be repeating this again. What will happen? The charge is brought from the cloud. Once it is brought from the cloud through the ionized path, already we have ionized path. Now the air surrounding these pauses, whatever the pause on the side streamer, next pause on next side streamer. So the air will again get ionized. That will be again ionized, and in this manner, from the cloud, the leader will reach to the ground. So leader will reach to the ground. Next is, once the step leader has made contact, once this step leader, so this is the step leader. Once the step leader has made contact with the ground, so what is going to happen? It's not as such clear. It is believed, it is thought that it forms a return streamer. That return streamer is shown here. See, this is a return. So once it touches the ground, then depending on the concentration of ion concentration which we are getting from the cloud center, and that will form a return. That is going to form a return streamer. That is going to form a return streamer, as we can see in the figure number. This second figure, B is this one. This figure we can see. Okay. And the path will be already through ionized path. The path here has got ionized, and through already this path we will send a return streamer. Now, as we can see, the negative charge which was present on the cloud, so most of that negative charge will be neutralized, or will be nullified by the positive charge which will be present on the earth. So this, when that will happen, that the majority of the negative charge which was present on the bottom of the cloud will be neutralized by what? Will be neutralized by the positive charge that was present on the earth. So that will give rise to the lightning flash which is observed. So at that time we can see the lightning flash. So because this negative charge on the cloud will be neutralized by the positive charge which will be present on the earth. So when the majority of that gets neutralized, then a lightning flash will occur, and then that can be observed, as we can see that lightning is going to happen at this point. Now once that is neutralized, once the charge has been neutralized, when the majority of the charge has been neutralized, so there that is the negative charge has been neutralized on the cloud, any further discharge, if there has to be any further discharge, that has to happen through same path. Figure C you can see. So if any discharge, that means if any further lightning phenomena has to occur, that has to occur through the same path. That has to occur through the same portion where the path is already ionized. Such a discharge now will have a very low concentration of ions. So ions will be of a very low concentration. Intensity will be very low. So then when the intensity will be low, so that will not be a branching. So there will be no branching in that return streamer is going up. So there will be no branching, and it will be associated that current will be high, but there will be no branching, no side streams. So that is called then such type of discharge is called a dart leader. In this case, it is called a dart leader. I will again repeat. So when majority of the negative charge will be neutralized by the positive charge which was present in the earth, so as such no further discharge will take place. But by somehow, if a discharge has to take place, then intensity of the intensity of that ions will be very less. That means those intensity will be very less, magnitude will be very less for those ion, and that has to come through the same path. Just like you can see, it has to come through the same path. So same path it has to come through, and it will be not branching. There will be no further branching. It will be associated only with the high current. It will be associated with the high current. Okay, Moomin?
Yes, sir.
Is it clear? Thoda theoretical hai ye. So
Yes, sir.
this. Now last part of it is, Now, if the discharge will take place, now this discharge, lightning discharge, will directly take place on the transmission line. Then what is going to happen? If the discharge takes place directly between cloud and from the cloud, it will go directly on the transmission line. Then power will be dissipated. So there will be dissipation of the power, and that will be dissipated in a very short time. And discharge will take place, that you already know. And the magnitude of that power at that time is given as 10 raised power 10 kilowatts. So it's a very high intensity discharge. So magnitude is 10 raised power 10 kilowatt. And at that time, it is obvious that it will damage the power system. That means transmission lines or insulators or equipments which are there will be damaged. And it is also doubtful that if any type of protection is provided at that point of time, any type of protection is provided, that is not going to have a much effect. That protection it is not going to have a much effect at that point of time, if that discharge will take place directly between the cloud and that will be on the conductors of the transmission line. So magnitude, you can see how much of power will be dissipated, very high value, and it is certain that the power system will be damaged, and the type of protection we have provided at that point of time will be least effect. The effect, it will not be effective. But what is happening? Majority of the strokes never take place directly on the transmission lines. They will take place, I have already told, God has done a very good thing for us. They will take place adjacent to the transmission line. They will take place adjacent to the transmission lines. And then with the result of that, what is going to happen? Passing, there will be an associated current, and that associated current will induce a voltage on the line, which will be of the form of a traveling wave. That means a wave will start from one side of the transmission line to the other side, and such wave will be produced by induction. So this is the main thing what we have to remember. I hope this is clear. Any questions? Mumin?
Yes, sir, it's clear.
So lightning phenomena is I'll be sending you the notes also, but from these diagrams, you have to understand that what is going to happen at this point of time. So there will be first potential gradient. I will highlight the main points. Potential gradient has to be increased, and there are ways to increase it. I have already told you, once the potential gradient will increase, it will exceed the critical disruptive value. Once that exceeds the critical disruptive value, then a leader will start, that's called a streamer, will start from the cloud towards the earth. Depending upon the intensity of that, there will be side streamers and there will be branching of that, and that is called a step leader. So one step will be, there will be branch, next step there are pauses, and there will be steps, depending if the intensity is very high, and when the cloud, which is having a negative charge at the bottom, will neutralize by the induction of the positive charge. Then when that will be neutralized, then what is going to happen? Once that will be neutralized, that negative charge will neutralize most of the positive charges. Then after that, depending on the intensity of the ionization, there will be a return streamer, and that return streamer will go through the same ionized path. One that will go through the same ionized path, then another leader, that is the dart leader, will come into effect. But if any further stream has to go, that will go through the same ionization path, and that ionization then it will that leader will no more be having any branches now, because the intensity will be lesser at that point. That's called a dot leader. So that's all for today's lecture. So we'll continue with some more one or two lectures we have where we have to understand this phenomenon. Then rest is very good theory that will be based on the non-shielding techniques, where we will have the lightning arresters. We will be working. We'll be explaining this work, how they work. That's a very interesting topic. Okay, let me stop this recording. Okay.